In this video, we're going to look at a worked example of Euclidean geometry. And so let's dive into it and how I would approach it. In the diagram, a circle with center O, and so immediately I'm going to stop and fill in my radii. So if that's 10, this would be 10. I'm thinking if this is x at the center, then this angle here would be half of it. And so I like to fill in as I read. I fill in as much as I can. Just makes my life so much easier later. And BC and AC are both 15, and so again what that's making me think is that these two angles here are going to be the same, so they'll both just be half x because it's an isosceles triangle. I could also say if this is x and this is an isosceles triangle that each of these would be 90 minus half x, but I'm not going to get too carried away at this stage. But it's good just to be aware that you've got another isosceles triangle, and they ask us find the size of x. And so what jumps out for me because of what I've filled in, and this is great advice as well, that you can always just draw a quick little picture. You can see how long it takes. It's probably taken me about 6 seconds. To work out x, this jumps out for me, cos rule. The cos rule specifically where you've got side, side, side. The one on the formula sheet is more helpful if you've got side, angle, side. And so if you've got 3 sides, this is the best way to lay it out. I spend my energy focusing on the next door neighbors of the angle that I want. And so it will be the next door neighbors squared over the next door neighbors times together. And then you need to minus the side you haven't used yet, and on the bottom you always times it by 2. That's just part of your formula. Why do I do it like this? Because I can in one shot just go shift cos of this answer, and in one shot I get my answer of 97,18 degrees. 6.2.2, find the size of ACB. And so now that I know that x is 97,18, then the angle at the circumference will be half of that. Everything that I'm saying in words you would have been writing as reasons. So just bear with me that there will be a lot more writing going on here. For everything you do, you get a mark for the reason that you've said it. And so if this angle is x, the angle A is half x. Reason angle at center is double angle at circumference. And so what is the angle at the circumference? It's just half of this. And so that's 48.59. And so what is angle ACB? Basically this entire angle here. Again, if you want to redraw a little triangle in seconds, you've worked out the A, that was 48.59. You know that these two lines are the same. And so this is also 48.59. That would be a reason in and of itself, isosceles triangle. Therefore, to get angle C at the top here, it would just be sum of triangle 180 minus 48.59 times 2. And that gives you your angle of 82.82. Last one, work out the area of BC, the entire shape. And so again, I would just be doing this in my question paper. I know there's a 15 there and there's a 15 there, and I know that I've just worked out this angle, and that is a perfect condition for using area rule. To do area rule, it has to be the included angle between the sides that you have. And so I can dive straight into getting the area as just half base times height, so it's the two next door neighbors, times sine of the angle, and that gives me my final answer for the area of 111,62. I don't know if it's centimeters, so I'm just going to call it units squared. I hope that you found that helpful, just to think through, talk through, fill in information as you read, to discuss how you can turn a question that looks a little bit complicated into something quite manageable, and the use in seconds of just redrawing little pictures like this to to make it easier on the eye and easier to see where you're going. If you found this useful, please like this video, subscribe to our channel, and share it with your friends. Thanks.